Hi, this is your host Swapn Bhartiya and welcome to TFR Let's Talk. Today we have with us Chetan Conikee, founder and CTO of Qwiet AI. Chetan, it's great to have you on the show.
Pleasure, Swapno, and thank you for having me.
Pleasure is all mine. I would love to know a bit about the company itself. How old is the company? What problem you wanted to solve, which led to the creation of this company?
The company is called as Qwiet AI. That's the name of the company, but we were formerly called as ShiftLeft. The word ShiftLeft, which is often used in security, which means move your security analysis to the left so that you become more preventative rather than reactive. We founded the company almost about 6.5 years ago. Our focus and emphasis was that there are many exploits that play out continuously in the ecosystem, and often that we see and notice in the press. We have security teams reacting to these exploits, meaning they work backwards from, are we essentially exploitable, and what do we need to do to ensure that our trust zones are protected. So as a consequence, we decided that, if a system can be built which conducts analysis of source code, which eventually becomes applications when they run in production, in the earlier phases of its software development lifecycle, we will be able to assess and discern potential security issues that might exist in the code with degrees of certainty. Now, furnished with that information, engineers can essentially become proactive, where when they're making design decisions, when they're writing code progressively, they make better decisions and treat security by first principles rather than something that they plug on later as a consequence of reacting to an event. So that was the genesis of the company. And my background has primarily been in fraud detection and prevention. I worked for various startups in the financial sector, which is investment and retail. And throughout many companies, I built systems to detect flaws and compliance violations. So I figured there is an opportunity to take all of what I did in the past, build a generic scaffolding, and potentially sell it as a product.
First of all, thank you so much for sharing the history and story of the company. Now, when we look at this security space, and you mentioned shift left, we talk a lot about that ever since the emergence of this whole Kubernetes cloud native. The whole security landscape has also evolved and changed. It's no longer someone else's problem. It's no longer an afterthought. It is become a priority. And when we talk about the whole shift left movements, are we really talking of moving a lot of things in developers' pipeline, whose pipeline is already quite busy, or we are talking about bridging the gap between the developer teams and DevSecOps team or security team? Because before we get into the whole autonomous application security and code proprietary graph, I want to understand the people side of the story as well, the cultural changes that you are seeing in the space.
That's an excellent question. As a matter of fact, I'm going to try to divide the answer into two parts, or I'll take your question in a different way. If I have to rephrase, your primary question was, who owns security? That's one part of your question. And the other part is, eventually, if you're speaking of source code, it is upon the owners of the engineer to mitigate, fix, and remediate the issue that has been highlighted. And engineers are already busy. They're not incented. Their bonus structures are not associated with security. So why should they? And through our progressive journey, we realize exactly what you're saying, which is when you have these detection tools which are inserted into the CI pipelines, which when I say CI, I mean continuous integration pipelines, eventually they furnish or they manifest as issues, and these issues are handed off to an engineer. And there are two consequences. One is you have a great security team staying on top of things, fixing issues. The other is they say, hey, it's not my problem. I'm just going to let it pile on, and we'll react to an event if it happens. So in our journey, we have seen both these situations on the spectrum. And the only way motivation is driven is if you have an interface that essentially both serves reward, which is incentivizing someone to do a job better. And the other is you create leaderboards and you gamify the process. Because we as humans have a tendency of trying to one up each other. So even if 1% of your team is performing really well and you lift up that 1% and reward them, you have the social mentality that kicks in and the others begin to do what they're supposed to do. That's the first part of your question. And this answer is pre-generative AI. Because if you remember when we spoke, there is the detection which identifies the issue, and the human steps in and starts figuring out how to fix it and remediate it in the best and the most effective way. With the advent of generative AI and transformers, now that task, that functional task, can be handed off to a large language model that is pre-trained. Now that large language model, scaffolded as an agent, is acting like a human being now. It has a role, it has a definition, and it is doing all what it needs to do and finally handing off the last mile to the persona who owns the particular task. So in summary, all the hard work and the grunt work is done by something, which is the transformer, handing off to the human on the last mile. And finally, your last question, who owns security? It depends on the scale of the company. If you're speaking early stage companies, the development team owned by the VP of engineering owns security. And as the company evolves, it gets enterprise customers, you need to be compliant. And then is when you hire a security team, you deputize a VP of AppSec with their own crew. And then the ownership shifts, where you have AppSec monitoring and examining the program, but eventually it is still developers who mitigate and remediate.
Thank you so much for, sharing the whole cultural aspect or the structure that organizations have or should have. Now let's go back to Qwiet AI. When I was listening to you and the way you folks work, it because once again in today's world, companies also, of course, everybody wants security, but security can be complicated. It can be challenging. And there is no direct, incentives they see. It's more like having a seat belts or brakes or airbags. You wish you had one when you needed one. So it is, it's very important to have those kind of practices in place. But yet, companies, of course, are also becoming cost sensitive. The whole cloud native complexity is also intimidating. So how does Qwiet AI, irrespective of whether we are looking at large organizations where they do have big teams, or we look at smaller organizations, they don't have big team, irrespective of which side we're looking at, everybody is becoming cost sensitive. Everybody is looking at lowering the complexity. They do also want to leverage these, emerging technology like GenAI. So talk about what role Qwiet AI play in kind of lowering the barrier of entry so that the security is not compromised.
We as Qwiet AI, we started the journey with, can we assess source code written in the top 13 to 17 programming languages and extract potential conditions that are vulnerable in the code? That was the pivotal point of when we started the company. With GenAI, or our latest version, we take all that information that we have identified and serve it up to the large language model and say, there is a potential vulnerability in this path in the code, and here is the context of the information. Can you suggest a fix? So the large language model now takes the onus of suggesting a patch, and that patch is served up as value elements to the persona. Now, your core question is, with the advent of generative AI, what is our value proposition? Because there are two parts to this. One is security is a crowded market. You have many companies doing many things. The other is security. The word cybersecurity is a fairly large umbrella, and it has coverage from endpoint security at the far right to software bill of materials to source code to containers and to runtime. And what do we do? What is our role in this whole gamut of offerings? We Our core technology is based on a scientific thesis called as code property graph. 3 words, code property graph. It was invented by a chief scientist emeritus by the name of Fabian Yamaguchi. And his conjecture was, like how Facebook analyzes a social network using a graph, and like how Google analyzes page rank by taking various pages that are connected over the graph and then serve up towards their business needs, can we analyze source code like that? Which is, we take the program written by engineers, we convert that to a graph, which is a maps like view, and now we place context information over the maps. Like, for example, if you're driving from a source to destination, you want to figure out the weather conditions. You want to figure out if there is potential constructions or accidents on the path so that you detour and adjust your schedule. Similarly, in source code, what you can do is examine your APIs, identify the underlying functions that are invoked as a consequence of that API being triggered, what parameters are passed, like user ID, password, etc., through the API, and what is the context around it? What software bill of materials are you using? Are you doing authentication, retry mechanism? Now we take all that information, plot it on the graph, and then with determinism, certainty, we tell you that this path is susceptible to this kind of vulnerability. Now this graph is pivotal. It was pivotal in the beginning and is still pivotal right now. Because if you look at generative AI today, it has become the sledgehammer. Many companies are coming out of the woodwork saying, I'm just going to take your code, give it as an input or serve it as an input to generative AI and give you insights. We all know it works sometimes, and most of the time it hallucinates. So which means more work to the engineer. So think of this graph as a RAG, or a retrieval augmented generation system. It is sitting on the side, pulling all that rich context and only asking a question in a very, very specific way, saying, here is a pathway. I see these elements in the pathway. I don't see this. What kind of potential vulnerability is it exposed to? So Qwiet AI is large language model with the graph, which means the outcome for an persona who's using the product is high signal and low noise.
And since, when we look at, Qwiet AI, it's more or less like, to ensure that the code hygiene is there. Now, when it comes to code, and most of the code that we use these days is open source. A couple of years ago, even Biden administration, they came up with the executive order for SBOMs. Can you also talk about how does the whole software bill of material, SBOMs, and then there are a lot of open source projects, PDX and everything else. What role does SBOM play? And if you can also explain the whole process. Of course, you talk about code property graph. We can also talk about autonomous application security as well there. Once again, the whole idea is that depending on the company you look at, I remember a couple of years ago, you'll walk to a company on the shows and you'll ask, what do you use? Oh, we are spinning this container. They don't even know what kind of libraries they are depending on, what kind of hard links. They really do. It's more or less like you talk to a car company and they don't have any idea about their whole supply chain. So that is also very important to know your supply chain. So talk about, there are a couple of things there. I don't want to make it too confusing, but the thing that I'm ask is that the role of SBOM, the whole software bill of material, and also that Qwiet AI focuses more on ensuring the code hygiene while the code is being written and deployed, not after the fact that it has been deployed.
It's a fantastic question again, and I'll break up that question into many parts. We'll start with software bill of materials. The trigger event for everyone taking software bill of materials seriously were twofold. One is the Equifax event that played out, and the SolarWinds event that played out. There are two different scenarios. Equifax was using a software component not in the correct way, leading to the exploit. SolarWinds was not protecting the CI pipelines effectively. Now, both of these does not imply the companies were doing a bad job. It was just so that the adversarial entity figured out a loophole and they took advantage of it. Now, typically when events like this play out, the consequences is you have the government stepping in and setting mandates and constraints. When these constraints are set, you have many companies that come up out of the woodworks and say, I'm going to take these constraints, measure something, and let you know whether you're good or not. In my opinion, that's just not the right way of doing things. Because you brought up a very important point. Let's take the car manufacturing industry into consideration. You have the car, which is you have the chassis, the engine, and everything else. And then you also have, your airbags, seat belts, and all of these are manufactured by the supply chain, not by those manufacturing the car. Now, when you take a seat belt and you install it in a car, you have to follow the installation manual of how the seat belt should be attached in the appropriate way to the seat. Now, if that seat belt is not appropriately attached, the consequence is it leads to fatalities and accidents and so on and so forth. So what happened was, due to the sake of marketing, when the bill of materials played out, everyone started blaming open source, saying open source is vulnerable, you have a blind spot, hence you are vulnerable. In my opinion, that works great to create or instill fear, leading to the buying cycle. But in truth, the open source library is built in a certain way. If you use it in the correct way, it works great. If you do not use it in the correct way, it leads to exploits. And most of the companies need to focus on explaining how the library should be used in the effective way so that it's not exploited. When we expanded our graph in the early days, we created a concept called as reachability. If you Google the word reachability back in late 2000s, we were the first to create that. Today, that term is hijacked. Every company out of the woodworks is saying we are doing reachability. But let me explain that. Typically, if you have an open source library that you're using in your source code, the first thing you do is you add it to your bill of materials, which is like a separate file saying, I'm using this open source library. And then you begin to leverage that library to serve your needs in your code. So reachability in principle is we look at your asset file. We say, are you using this? Second is we say, is it vulnerable? The third is we use the graph and start looking inside your source code saying, are you using it the right way? Like how I just illustrated with the metaphor of a car. We say, are you using it in the way that the author expects or has prescribed to use it? Now we take all of these, have weight scores to it, and statistically identify whether you are susceptible to a vulnerability or not, which is what we call as reachability. And there's a science behind it. Unfortunately, much of the marketing today tells you that we're doing reachability, but they don't explain the science behind it.
When we look at AI and when we look at Qwiet AI, now AI can be seen from two different lenses. One is AI as a workload. Companies, they are running AI workloads. AWS reInvent is going on. A lot of discussion going on. And second is leveraging AI to protect those workloads. So how does Qwiet AI look at AI, GenAI?
Again, fabulous question, Swapnil. Just to break down what you just asked, right? AI is at the fore, both from a marketing, from a positioning standpoint, because of the invention of transformers. Transformers were like this sledgehammer where you can essentially build anything over it, anything under it, and anything around it. So in context of, transformers, many businesses are created where they're creating models to specific domains. And then you have what they call as the picks and shovels, where in order to interact or inference with a transformer, you need prompts. When you need prompts, you have to ensure that you're prompting in the appropriate way. And then you have security that comes with it. Can someone else inject something and extract PII information out of your system? And you have your checks, balances, and controls. And finally, the other aspect is you already have an existing legacy business and you want to leverage large language models or generative AI to serve your customer better, which is change the experience fundamentally. So as far as Qwiet AI is concerned, we are doing two of those things that I described. One is we have trained a model to take information from the graph and make suggestions of how to fix your code in the most effective way. Along with it, we also do one thing, which is detect hallucinations. Given like what you said, generative AI, in a very simple metaphors like a text completion system or a next token prediction system, where when you're writing a letter, it does a fantastic job of curating and adding a new context to it, even if you just prompt it to do. Likewise, when it's trained on code models, it can generate code too. But the consequence is it can sometimes just make up an open source library that doesn't exist. That's what they typically call as hallucination. Now, what attackers are doing is they figured out this loophole and they are running workloads questions with many, many models and seeing patterns of inventions of the large language model. If it just makes up something, they take that name and they do something called as typo squatting. They go create a library in the ecosystem. They host it with that name and they plant a backdoor. So now you might think the large language model is actually making up something, but in reality, the attackers already prefabricated what it is made up. So the dangers are imminent, but it's important that whatever generative AI is generating needs to be eyeballed, which means we are still not in the era of full autonomous mode where you can completely depend on generative AI. You still need to pretend to be a caretaker by observing what it's generating.
Perfect, thank you. And which also kind of lead to another question, which is when we look at the attacks that are happening. I don't know how much is that within your radar, because you folks don't deal with after the attacks, but attacks are also becoming sophisticated, and typo squatting and a lot of tons of things are happening. A lot of cases happen where in the container, the hard link will change to the malicious, repository versus, the authentic repository. How much Qwiet AI can do at that stage to address or deal with some of those things that happen after the code is deployed? Or, once again, security is not as easy as we used to think. It's very, depending on who you talk to, some folks will go, oh, security is the easiest thing. But I always believe security is not a destination, it's a process, it's a journey. Second is that as good guys, you have to be right 101% time. The bad guy has to be right only once. So the balance is very much offset there. So talk a bit about these sophisticated kind of attacks that you are seeing, where you have to also think of those, at the very early stage itself.
Like you stated, right? Whenever anything new is invented, the consequences is you have adversarial entities trying to figure out what are the best ways to leverage that system in a malicious way. Now, if you just extend that with an example, with transformers, they've figured out ways to compromise the model. The other issue is if you're dealing with prompts to communicate with the transformer, can you inject in the prompt in creative ways to extract information from the system? So the degrees of sophistication depends on the complexity of what you are creating as, an industry per se. And in our case, as we see this evolution play out, what we also try to do is mine and extract information from these systems to identify patterns which are generic across these systems. So for that, you need multiple lenses. One lens is the defender lens, which is something that we already have as a core strength. Our defense system is trained on many, many CVEs and CWEs over the past 6 years, that we are able to identify and predict likelihoods of vulnerabilities that might happen before it happens. We typically call that as pre-zero. The second aspect is assume that a vulnerable code is deployed to runtime and production. It does not mean you're attackable. You have to understand the topology of your production ecosystem, which means, for example, if I have a vulnerable application, if it is deployed in a virtual private center, virtual private zone in Amazon that is not exposed to the internet gateway, you are not exploitable immediately, which means that can wait. Why? Because your network controls are effective enough to prevent such things from happening. So context is key. You have to look at the network topologies. You have to look at the application vulnerabilities. You have to look at the container vulnerabilities. And then you causate and correlate by connecting all these together and saying, is this urgent? Does this need to be fixed right now? Or can it wait?
What are the new use cases that you are seeing that worries even you, where you, I mean, not necessarily lose sleep at night, but you're like, hey, these are the new emerging use cases, new vulnerability that we should be prepared for?
Couple of things, right? One is, given that we spoke of the fact that generative AI has become a sledgehammer, like meaning if you're building a product, if you're retrofitting a legacy product, if you're not doing generative AI, you're not considered relevant anymore. That means you're taking every data that you have and you're pushing it into this machine, this training machine. Either you're inferencing through it or you're training your own models with your data. But when you do such things, you have to be very privy of your customer data you're dealing with. Is that going to expose your customer transitively? And today, of course, you will react to compliance, but there is no forethought. People are not thinking on their heels to ensure that such things don't play out. They're just trying to figure out a way to augment their business, to increase their opportunity. The other is, if you want to change your experience, in your website, earlier assume that you had a Tableau dashboard where you're showing insights. Today, you are pushing forward this agenda of an agentic AI, where you give your agent a personality and name, you put that in your user interface and say, hey, chat with your data, right? Now, the question is, do you have sufficient controls to ensure that someone can compromise that interface? And by that, I mean, do you have profanity checks? Do you have checks and balances so that a certain question would not lead for data spillover to happen, where someone's seen someone else's data? And the deal is, most of the time we react to events where something is released in the wild, and then you have an adversarial entity or someone else figure out a way to abuse it. There's a blog article that comes out, it catches wildfire, and the whole industry reacts. So instead of operating that way, you'd rather start thinking through at the design phase itself. How do I explore putting those right controls in place so I don't face such a consequence later? And fortunately, generative AI can help there as well, where you serve it the design doc and say, where am I exposed? Help me understand that. And that puts you in a better position where you're not reacting to events, but you're more proactive.
As you mentioned, the company was created in around 2016, which is like 2 years after the whole Kubernetes and CNCF, came to exist, and the whole cloud native kind of, you could call it revolution or movement is started there. How you have seen this whole landscape evolve? Because new use cases, new technologies also mean the way people are doing security, the way people are writing code is also changing. Now we also talk about visibility. Initially, Kubernetes was all about stateless workload. Now we are talking to stateful workloads. So talk a bit about how the industry has evolved. And that also means that Qwiet AI has also evolved with the evolution of the industry and market.
Definitely. Like you stated, right, it was at that junction or precipice where Kubernetes came to fore. And Kubernetes disrupted, vendors who are doing resource scheduling. For example, someone like Amazon says, spin up a virtual machine, we'll take care of things. Someone like VMware said, spin up a virtual machine, we'll take care of things. But that we'll take care of things was a black box. You had no visibility because they were running a hypervisor. Their secret sauce was effective configuration of the hypervisor so that, all of your workloads work effectively and auto scale. What Kubernetes did is lifted that wheel. They essentially built an open source hypervisor and said, this is how you schedule stuff. They created new vernaculars like pods and other stuff from their ecosystem standpoint. And then the community came behind it. And now you can take your workloads, which are Docker containers, which became very popular, before Kubernetes came into being. and deploy that Docker container, scale up, scale down, depending on your network demands and needs or your seasonality. So that shift happened where all of the vendors started essentially accepting Kubernetes. Some of the customers started deploying Kubernetes on their own chassis. And for us, right, we were agnostic of that because eventually it's the same application written in programming languages that used to be deployed in AWS or VMware going into Kubernetes. So for us, from an opportunistic standpoint, we worked both in the Kubernetes world and in the legacy world because we were analyzing applications. But the additional value that we provided is we started examining even Docker container images to say, check your images, let you know if you're potentially vulnerable to conditions that exist in those container images. So no fundamental shift for us. We sorts of worked in both the worlds.
I think I have touched on some of the key points that we wanted to cover today. Is there anything else that you feel like?
I think fantastic questions. Every question, hits the nail on its head. Of course, I'll touch on one more aspect, which is when we built Qwiet, right? Our initial focus was, can we serve the need of a customer, which is identify vulnerabilities with high signal and low noise. And then, like you stated, security became a multidisciplinary concern where you have to look at source code, you have to look at bill of materials, container images, and now generative AI. So progressively over time, guided by our customers, we have essentially become a foundational platform. The underlying graph is serving all these use cases. So instead of you as a customer buying 5 products and then buying a SIM where you aggregate that information and draw insights, now you just buy this one single product with the graph, and then you extract all of these insights in a connected way.
Chetan, thank you so much for joining me today, and of course, talk about Qwiet AI and the whole security landscape, how it has evolved, and how you folks are helping teams. Thanks for great insights, and I'd love to have you folks back on the show. Thank you.
Thank you, Swapnil. Thanks for having us.